table. So moving from the OMOP tables to, you know, the flags that we needed for our analyses or certain values that we needed. Sometimes we need more than just a single row per patient. So we have an events level table and then a person level table. And already continued refining the structure over time. And as we got tips from Saad and Sean, and then informally created this logic liaison group of coders, we incorporated their tips and best practices. So this is a work in progress, but we think that if people adopt it across the Enclave, it will help us all have work that's more consistent with one another. And as we, you know, find issues with it or better things that we can add to the template, we can all improve on it and continue releasing versions of it. So we welcome your input and or requests for things that would really accelerate your work. The goal is not to do analytics at this stage, but just to create the data frame that will then be ingested for analytics. So it could go into a machine learning pipeline or into regressions or other statistical analyses. So that's my little background pitch. And Artie is a graduate of our School of Data Science at UVA, and we're just really happy to have her working with us in Enclave.
Hello, everyone. So yeah, thank you to Saad for building this template, building the template for the Cynthia data, because earlier this week it was only enabled for level 2 and level 3 data. And he made it possible for you all to be able to practice with it in the training DUR. So thank you. And also Sean made the manifest table for Cynthia data as well. So thank you to Sean too. And like Johanna said, this is a compilation of different ideas that the Logic Liaison team has discussed together. So if any of you have any other suggestions at any point, feel free to interrupt me with comments or questions. I'll share my screen. So some of you may already know how to go through how to navigate the Enclave, but I'll just quickly show you how to find the template. So when you're on the home page, you can go to the knowledge store. Also, if there's any background noise that makes it difficult to hear me, just let me know and I'll quickly move. I'm in a public space right now, so there may be some noise in the background. So once you're in the knowledge store, you can type in person or person level table. The name of the template is multi-node template for person level table. We may change that to logic liaison person multi-node template. So look out for that change, but you should be able to find it with these keywords. So once you find it here, you can click on it. I actually have this tab open here. So, so once you have this page open, I'll just show you what the attached documents we have here. So on the left side, in the overview tab, we have the templates themselves. So we have de-identified for level 2 data and LDS for level 3. And then we have the README that has all of the tips and best practices that we've compiled from the Logic Liaison team. And then it also has the step-by-step directions on how to use the template. And then we've also included attached sample code books for level 2 and level 3. And you can open those alongside with the README to see the references in the README and to see what the code actually looks like. But for today, I will show you the Cynthia sample code book that's organized for us. And I also have the README open. So I'm going to go back and forth between these two. So once you have this open, I think it's definitely worth it before you actually use it to skim through all of these details. It's probably like a 10-minute read or so. I'm not going to read everything word for word, but I'm going to try to get the main points across. So the goal here is to, and if Johanna or someone can keep an eye on the chat and let me know if something comes up. So the goal here is to create a person level table for your analysis. And our goal in the Logic Liaison team is to include all of these facts about the patients that would be commonly needed throughout the community for different types of analysis. So of course, we're all interested in the COVID-19 related facts, so we've included that. Things like the date of the test and the result of the lab test. We've included the BMI, reported BMI of the patients, whether they had a reported death, common procedures like ventilation and ECMO, information related to what type of visits they may have had. And we've also included the comorbidities that were included in the cohort paper. So, and I'll show you the logic involved with all of these in a little bit. So if you have any suggestions that you feel like you've been using in your DUR that you think would be useful for the rest of the community, please do let us know and we'll try to incorporate it into the template. So there are three questions that we asked you to think about before using the template. And that is one, once you already have a DUR, you most likely already have one or more research question in mind. So just, this is just asking that you keep this in mind as you're trying to figure out what you want to incorporate into your person level table. And along with that, we also want to know who are we actually trying to study? So who are the patients of interest? What is the inclusion exclusion criteria? I'll give you a couple of examples. In our prior projects, Johanna leads the neurodomain team here in N3C, and one of the main analyses that she's leading there is for stroke in COVID patients. So for our person level table, it was really important to include patients that had either stroke or COVID, or both of those. And that made it easy to switch back and forth when we're actually using the person level table for analysis, that if we're including only stroke patients or including only COVID patients, because we have indicators for both, we can easily switch back and forth because we've made the master table something that's more inclusive. So essentially what I'm trying to say is that we use an outer join and find patients that had either or both of those conditions. And this template also allows you to do the same, where if you are interested in COVID co-occurring with one other condition, then you can, the template is editable where you can enter in the other conditions that you're interested in. And so the last question that you should think about is also, what other variables or patient facts are relevant to your analysis? So the ones listed up here could be these supporting facts that you need for your analysis. These could be independent variables, dependent variables, matching criteria. So just something to keep in mind of what are all these other attributes that you're interested in knowing about your patients of interest.
Can I interrupt you there, Artie, real quick?
Yeah, go ahead.
So one practice we have in our projects, and often there are multiple analyses going on under a single DUR. We're working with the teams early on to not just define those concept sets using Atlas or other tools, but also to think about the logic carefully, like the timeframes around things or the relationship between variables, or how we'll deal with nulls. And sometimes you can't make all the decisions up front, but you can try to, and then plan for things that you'll investigate. And deciding the variable names and creating a little data dictionary for your team is very helpful, because then once you have a person level table, you have this document to refer back to, and the people doing the analysis and the clinicians and everyone will be on the same page. So that's something we recommend.
Yeah. And also these supporting facts could come from any of these domain tables. We've included, I think most of them, conditions, measurements, observations, visits, and drugs in our template. So it should be able to support any of those domains that you need facts from. So,
may I ask quickly, how are you handling missing data? Just a
so
blank.
yeah, that's a really good question. We have yet to discuss that in our logic liaison team to see if there's a common best practice that we've all discussed. Our template here is sort of there to give you the person level table. So any missing data that you have to think about how to work with that for analysis would be a separate discussion. But if you feel that there's common best practices, then we would welcome suggestions of incorporating the code that you need to do whatever, however you are handling missing data in your analysis. And we could also incorporate that into this template too.
Yeah, often having just the visualizations at this stage to look at that is a good thing, but the biostatisticians are typically the ones who need to make a decision on how to go.
Right, so I'll hop into the logic liaison tips. So these are some of the things that we've discussed in the past couple of weeks when meeting with our team. These are all really important to keep in mind when you're doing analysis. So some of you may already know a lot of these, but just a couple I'll name out here are the date shifting that occurs in limited data set, L3 data. Our template incorporates the manifest table, and I was able to show you this today because Sean made the manifest table in the Cynthia data. So this will give you the max num shift dates per site. And what we've done in the past is, I mean, this is something to discuss with your team and the people that are doing the analysis, but this is something to keep in mind if there's date shifting occurring in some of the sites that are incorporated. So other things are that be wary of cutoff dates because each site has a different cutoff date. We've also had a lot of discussion of how different sites use different data models. So one site might support a certain field, whereas another one might not. And then these are, another important we've discussed is how death data is incomplete because there's a lag of reported deaths that comes after some of the other information that you'll see from the other domains. There's a couple more here. Lab dates might represent date ordered and not the date of the result. This could vary by site. And then a very important one is the absence of effect does not mean it's a negative. So that speaks a lot to the death data too, since there's a lag there. So I would definitely recommend giving this a read before you start your analysis. So here's where the directions start of how to import. And you can, there's two ways to do this. You can either find it in the knowledge store like this, and whichever level of data you have in your DUR, you can click on L2 or L3. And once you're there, you'll have the option to import into a new workbook, or you can follow these steps where you open a new code workbook in your DUR, and then there's small fine print in the middle that says skip this step, and then you can click on new transform, and then you can search for the name of this template import into your workbook. So now we'll start explaining the order how I usually start. So another thing that Sean did for us, thank you, is I stole this idea from him of randomly sampling patients before finalizing your data set, because it really helps with just checking to see if your code is running correctly. And if you are having slow run times, then it just saves a lot of time just to finish debugging and making sure that you have all the logic correctly. And then once you're ready to start it, once you're ready to start on the full data set, you can run on the full data set by, I'll show you what the node looks like. So here, when you have this open, we made these two parameters where the percentage of data set that you want to randomly sample, and then also a random seed so that you can have consistent results each time you run this. And this is in terms of decimals, so this is actually 0.1%. So if you wanted to run the full data set, you would just put in 1 here and run in this node. So now that we have that, I'll explain the color scheme here. So when Johanna and I first started working in the Enclave, it was really difficult for us to organize all of the nodes and be able to jump in and know exactly how to look for what we needed. And so we developed this scheme where the workflow goes from left to right. And so the rightmost table are the ones that are either your final table or some visualizations. And then the leftmost tables are your input tables. So in this workbook, all of the red tables are N3C input tables. I'm not sure if you can see it clearly, but you'll see the location, person, condition, and all of the other domains. And once you have both of these templates, the L2 and L3, will import the respective L2 or L3 input tables for you. So you won't have to look for that. Once you've, I should also add that when you actually import this into your own code workbook, the color won't be preserved. That's a feature that will be added in the fall. For now, you won't have the color and you'll have to make this color scheme yourself, or use one that makes sense to you. And that's really easy. You can just right click here and then edit and create color group. And then once you've created the color groups, you can just keep adding to the ones you've made. And then also the orientation might be a little shifted. We've seen that the order from left to right stays consistent, but some of the tables might be higher or lower than what you see right now. So, okay, so we've explained the red tables. I see the chat is going off, so
It's okay.
Just let me know if,
yeah, we got it, Artie. We'll let you know.
okay. I just wanted to make sure there weren't any questions for me. Okay, so thank you. So next is the orange level of tables. And like I was explaining earlier here, when we're making our cohort or master patient group, we've been using these terms interchangeably, but we mean the same thing. Essentially, it's just the patients that you're interested in analyzing. So again, the inclusion-exclusion criteria. For your analysis, it might be that you're looking for only COVID positive patients that have been put on a ventilator within a certain time frame. So if that is your case, then what would happen is you would have your measurement table, because that's where the lab tests come from. And then you would use your procedure table, because that's where the ventilation procedures are stored. And both of these would be the input tables into your master patient group here. So the template is designed to incorporate all of these domains. I'm actually missing visit here, but I will be adding that. So that it's flexible and you can choose which of these domains make sense to use for your master patient group. For this example, for the template that I have here, for this example, we've included patients that have had a COVID diagnosis, have had a positive COVID test, which is the PCR or AG test. And there's a concept set that is included in here. And then we've also included a space to enter this condition 2, we've called it, but the default for now is the code set ID for ischemic stroke. But this template is editable. So when you have this imported into your workbook, you can change these and be able to rerun it and get the respective correct information. And if you want to see the code for this, you can toggle view. And if you're someone that wants to see the logic behind this, which I would recommend to make sure it fits the definition of what you're looking for in your analysis. So here you can see that I've added these outer, inner, left, and right. Well, this is supposed to say right. Of different types of joins that you can use to create your master patient group. So like I was saying earlier, we have used an outer join because we wanted to check for patients that had either or of the conditions of stroke or COVID. So you can change this according to what your definition might be. And then if you do want to edit the code, what you would do is click on actions and then change, so convert to code transform. But just a warning, once you do that, you won't have this interface anymore because it gets converted to just a regular code transformation. So
Can I add something there, Artie?
Yeah.
And so our intended audience here are people who are going to write code in code workbooks, but we want to accelerate that time from first entering the Enclave and watching some trainings to the point when they have a person level table they can begin analyzing and making some decisions about, as mentioned before, about missing values and other things. So, we had a lot of trial and error to get here in terms of what was going to work and using PySpark when we're used to using Python. And, we know that we're not the only ones who sometimes struggle with a new environment or just learning what works. And so the point of this is not to just assume that you're going to be able to come swap a couple code sets and be done. Maybe very few projects, but maybe that will work for you. But more likely you'll need to go into the code, but at least now you have running code, you have commented out code that you can add in if it's applicable to you, explains what it is. And because this code all compiles and runs, it should be much easier to modify it. One other thing to mention is that we always iterate in these projects, or we add new questions under a single DUR. And in the past, we had these sprawling code workbooks where every time we added a new idea, like, oh, we also want to include the patients who were had ED visits, not just admitted patients or something, right? Every time we added a new concept, we tended to have a new transformation node. And so we got these little blocks of code all over the place and we could never find where they were. So again, this structure is a place that you can always have the same architecture to this. And when you need to iterate, you just go back into one of these cells, into one of these nodes and modify that code. So over time, your master patient group is probably going to grow as you might be more inclusive or have more rows of patients. And then a single analysis can use the flags that the code generates to narrow those down and say, I just want to look now at the ED visits, or I just want to look at the patients with some other characteristic that I've created a flag variable for. So, the person level table can be quite broad and provide you with all the facts that anyone in your team might need to use to answer a question. But just those 2 points. One, you're going to need to modify code, surely. And two, that at least modifying, copy and pasting is easier and iterate, but instead of adding new nodes, when you iterate, go back and modify those existing ones. So you always have the same structure and anyone in your team can go and know exactly where to look, say, for all of the conditions that were part of your inclusion criteria for your cohort.
Yes.
And Joanne, I have a question actually on this particular example. So in this one, let's say that I wanted to have my cohort be people who had a COVID diagnosis or got a particular drug. Is this the actual node that you would swap out the input table for to do that?
So you would, if you didn't need any other condition besides the COVID diagnosis, then you would remove that condition too, because it's not part of your logic, right? And you don't need that join. You just need, at the conditions level, what are the facts that are going to be needed to determine the right condition? And then the drug definition table here, or drugs of interest, or whatever it's called here in the orange, that's where you would put the drug criteria. and then she'll show you where they converge in the yellow. So each of these are independent transformations on a single OMOP table. Again, that helps just kind of keep everything really well organized, so you would know exactly where to go to look for a drug you filtered on for your patients, or later maybe a drug that you needed as a variable. Does that make sense? This one's just for, the previous one was just for conditions that are part of your inclusion or exclusion criteria.
Yeah, so I think everyone's criteria varies a little bit. So I like to make this template as generalizable as possible, but like Johanna said, it's always going to require some editing and some tweaking and some changing of the code. So for your example, Sean, you said it was for COVID positive patients. So if you're using both the diagnoses and the lab tests, then you would incorporate the condition error table, the measurement table, and then also this drug error table. So in this example, I'm not using drugs, but if you change this code, and then here you would add, like I can't edit it here, but you can type in patient group definition drugs, and then you would be able to add that code here because you've already selected those patients from this node. And then here you can do inner join, outer join, whatever fits your definition. And just to explain why we've structured it in this way, there was maybe like a couple of months where I felt like the run times were just starting to get a lot longer. And part of the reason is because it's kind of a trade-off how you structure this. Like at the beginning, we were making a transformation for every single variable that we created. And that slowed down the workbook because there's too many nodes, and there's just a lag of every time you click around on something. And then the other way of doing it is to try to compress everything into the domain that it belongs to. So you'll see that I only have one node for all of the conditions. I only have one node for all of the observations. And we're only querying for those attributes out from the master patient group, because those are the only patients we're interested in. So instead of querying through a data set that might be like 100 million rows, you're querying through just a couple million, because you've already defined who you're looking for and what attributes belong to those patients. So the idea is to make the table a little more lean as you go towards the right, and it helps your runtime, and it just clearly defines the process of creating this person level table. So,
exactly. So just to clarify that, we first had just flags for everything that were created all at the same time, whether it was a flag that defined who the person, if they were eligible or not, or all of the derived variable flags, all of it was being kind of created in these single transforms. But now she has the orange and yellow layer to narrow down to just the list of patient IDs that we need to operate on. So we have greater efficiency from everywhere to the right of the yellow.
Right. And like Johanna said, like it's an iterative process. So if your definition of master patient group changes, then you would just go back to the orange level and say like, oh, I actually am interested in patients that were on this drug and also who went through this procedure, and then incorporate that, connect these nodes into the master patient group. And then you would just repeat the process of going from left to right and running these tables. And the information that pops up in your person level table would be that information respective to the patients you've selected here. I'm going to explain the color scheme as we go through all of them. So we've just been through the red, and this section explains how we're selecting patients of interest. So I touched a little bit on how to change these parameters based off of who your master patient group is. And like in Sean's example, you can add the drug era, if that's what your definition is. You can add procedures. And once you have this table, This is usually just aggregating by an outer join, left or right or inner join. And what I tend to do is I create the derived variables as I go from left to right. So whenever I have the information I need to make a variable, I just create it earlier rather than earlier than later. So one example I'll give is a variable for the time difference between the COVID first date of diagnosis and the other condition. So in our case, let's say it's the first stroke date that the patient had. And this will give you that time period difference. So as you build out the variables, you can create derived variables even before you get through the third or fourth levels of the workbook. And then the same way you can also add indicators. Like for here, we were interested in patients that had a stroke within 3 months after their COVID or within a week before. And this just makes it so that it appears as 1 if it did fall in that time frame, and 0 if they didn't.
Again, it's going to be different for your study, but we've reused
Yeah.
this across different studies. Sometimes that need, totally 1 week before and after or anything, but it's much faster to just modify this existing code and change your comment than to start from scratch.
Yeah. Right. So you're going to have any number of different derived variables. And again, if you have suggestions on something that we can incorporate in here, then definitely let us know. So this just explains in more detail how you can get different facts from the different tables, like different domains. And then we've explained this part where you're aggregating it into your master patient group. And then the next level, which is the green level here, it's called Find Patient Facts. This is related to the third question we had above, where it was what other variables or patient facts are relevant to the analysis. So for some people that might be matching criteria, that might be an independent or dependent variable. In our case, we've included these comorbidities from the cohort paper. I was trying to click there here. And then we've included the patient BMI. And some of these comorbidities are cross domain, so you might see it in the conditions table and an observation table. So one of those, I think, was end-stage renal disease or maybe obesity. Yeah, so obesity is a condition, but it's also an observation. And you just have to check for it in any of the tables it might be coming up. Here's where the ventilation and ECMO procedures are. And then for those of you who need to filter down to specific types of visits, like inpatient or ER visits, this is where you would do that. And I'll also show the corresponding code to this too. We also have the death table to see if there's a reported death for the patient. And again, there's a lag for death data. So just something to keep in mind so that if you have a false negative, it doesn't mean that there wasn't an actual death. And yeah, so I'll go into the code here. So in this code, you'll see all of the parameters here are going to show up on this interface where you can change. If you have a different definition of, let's say, PVD, you can replace this code set ID and enter it here and rerun it. And the way I've set up the logic here is to find the earliest date of diagnosis for these comorbidities, because to us, it made sense that you needed to check for this before the COVID diagnosis, because it wouldn't be considered a comorbidity during their time of COVID if the diagnosis occurred, let's say 6 months after or a year after. So I looked for the earliest date that this occurred, or the earliest date that this was reported for the patient. for all of these, and then aggregated it here, and then I just made indicators for if it occurred before their COVID and before their condition 2 date. Whenever I say condition 2 here, I just mean the second condition that you all can replace with something that's relevant to your analysis. So yeah, I'll also show a couple of the other ones. It's sort of the same idea in these other nodes too. You can replace these code set IDs, convert it to code transform if you need to add other conditions here, or sorry, other observations. We have the visit of interest table here. Right now, we're including these as inpatient codes. There may be other ones, or there may be other things that you might want to include. In that case, then you would have to convert to the code transform and add it into this space. Oh, and then also I'll mention this table. So this is the Cynthia data, but in level 2 data, you'll be able to connect to the location table. I think, is there a location table? And yes, there is. So you can do it in this workbook as well. There's a location table here, and you can get the synthetic location for the patient. And then for level 3, you can connect this. There's going to be commented out code, I believe, here. Yeah. So in level 3, you'll be able to use this code that you can connect to the postal code table, where you can get the latitude and longitude, and you can use this to make heat maps for the locations of the patients. And then I think that sums up the green level here. And then once we have that, we aggregate it all into what we call the master fact table. It's the blue level. And we usually just use a group by, or sorry, not a group by. We've used left joins because, and we're able to do that because we've already selected the master patient group. So now we're just tacking other attributes onto that table. So everything you've queried for in the previous level, you can add here, and add whatever derived variables that you need to go along with that.
Yeah, that's a great point. That's a big efficiency gain from having the master patient list already established now. So you can just do that type of join, much more efficient.
Yeah. Also, I forgot to mention how the measurement table here, measurements of interest table here, I'm using this to get the BMI of the patients. And I know that for some people it's been a struggle because the run times are can be really long. And I have Saad to thank for this because he helped me a lot with troubleshooting slow performance, and we were able to get this up to, I think, like 15 minutes, whereas before it was taking several hours. And this is also 15 minutes to get BMI, two reported BMIs per patient. So it's, you know, double the information and it still runs pretty quickly. And then I'm just checking to see if I'm missing something.
The master
So-
fact table can have multiple rows for each patient because you may need to look at several rows of data before doing some final logic to create a final flag, or you also may want to preserve those multiple rows of data for some of your analyses. So maybe you know, you might have something where they're statistically looking at changes over time in a measurement for a single patient, and you may need to have multiple rows of data. So both of these, the events of interest and the person level table, might be the ones that are ultimately ingested into your workbooks where the analysis is done. We do recommend splitting this logic liaison work that you do splitting it from your analytics, because it can help if you have multiple people who are using these facts. It can just help organize it, and everyone can know, you know, when was this updated. You can create branches if somebody needs to use an earlier version of your table or a workbook. But it's less confusing than having all of the analytics blended into the same workspace.
So
Jared's asking, Jared asked, are the 2 BMI values retained by this transformation date restricted? I'm not sure. I did not work with you guys on that.
date, sorry, what do you mean by date restricted?
Oh, is there a reference date that they're looking at and then have like a year look back or something to that effect?
Yeah, that's a good question. So I think in this code, I'm just looking at the closest one to the index events. So for this, it was for their initial COVID diagnosis and for their stroke, or here we're calling it condition 2. But alternatively, what you can do is add an indicator that shows what that time difference might be, and then add a cutoff and say, like, you know, I'm looking for something that's only within 6 months or 2 months. But I did follow some of the logic that Steve Johnson included in his BMI template, where we're cutting off these values for height and weight, because it seemed like anything outside of those bounds wasn't as accurate.
Okay.
And also because, another thing is that this is for adult BMI. So these thresholds wouldn't make sense for getting pediatric values.
Okay. Great, thank you.
That's a great point, just to see how different people's work have flowed into this again, in addition to folks on this call. And there are a lot of different people who've developed things in the Enclave. And if we are frequently using them, we find it easier to have it all in one template here, instead of trying to pipe together a lot of different templates that are coming in from the knowledge store. So, you know, if there's really frequently used things, we do intend to put them in here just for the ease of use, for new users to not have to go hunt and find them and then create their own daisy chain of templates. It will never include everything a team wants, but the frequently used things we'd like to get in here. So if there are things that your domain team is using, I think I already said it before, if you're using a lot, just let us know. We'll try to add it in here.
Yeah, but thank you for that question. It's good to keep in mind different criteria that some people might have. So yeah, so just another quick thing is it really helps to keep the information that you need and drop what you don't, so that it doesn't, you don't get lag in runtime. So here I've just dropped a couple of columns that we don't need. And then in our almost last step, where we aggregate everything, we use a group by to get all of these indicators and in some cases dates. For all
show
these,
the preview of this one, Artie? I want to show them. This is Cynthia data, right?
yeah.
Okay.
Yeah, so in here we have the person ID, the data partner ID, the earliest dates for the index events. So for COVID, it would be their first COVID diagnosis date, and then the first date that they had a stroke or some other condition, and then indicators for all of these comorbidities. I think we have a time variable here. Yeah, this was the time relationship between COVID and condition 2. I'll skip through these comorbidities.
Julian,
Julian,
I think you mentioned the missing data. So in general, like the missingness of a fact doesn't mean it didn't happen, right? We don't know about every condition somebody has. So the ones are just representing the known facts. And so we always, in doing analysis, have to think about what may be unknown. And we may need to filter our patients down based on some judgment, like, okay, we're going to only look at admitted patients because there's rich enough data around the admitted patients, or patients with a certain number of visits, and different criteria can be applied. And it might not apply to every analysis that your group does, Also, some of these things might be independent variable in one analysis, but in somebody else's might be the dependent variable, right? You might have something like ventilation be independent or dependent variable. So this data frame doesn't make those kind of analytical decisions. It just sets the team up to have kind of a set of facts and that will match up with the data dictionary that they are creating over time with clear definitions of the logic and also the links to the concept sets. We always put the links to the concept sets that we're using right in our data dictionary so that clinicians can refer back and make sure that they're talking about what they think they're talking about in their analysis. These zeros and ones can be used and ingested into a machine learning pipeline as features or however they need to be used. And something like the dates, you might end up partitioning your data frame into the pre-COVID era patients and then your control patients from the COVID era, right? Or that type of thing. Or you might use this data frame to make a matched sample and thus your analysis would just have a subset of these rows of data in your final analysis. But this is just the starting point. And it's everything you ever would need to know to make those decisions moving forward with your team and analysis.
Thank you.
Yeah, and Sean, did you have a hand up?
I did. I had a question about, so I mean, obviously you guys aren't going to want to say like, oh, if you use this template, your research will be perfect no matter what you do. But on the other hand, there's obviously sections in here where there are best practices that that the Logic Liaisons team have discussed and sort of put in. And I'm thinking around stuff like inpatients and, COVID admission and stuff like that, where I wouldn't necessarily know if I were to use this template, the right way to do that. So is there guidance about like, this is a best practice way that, these groups have decided to do this kind of thing versus other things where like, this is in there sort of, you're going to want to change this for your own needs?
So none of those judgments are made here. We're not making any decision we're not making an analytics decision. We're just creating a data frame, but there are tips around even our variables, right? So a lot of these logic liaison things like the date shifting, when you're level three data and you're assuming I really do know if we're in the COVID era or not, or some kind of real world date becomes very important to your analysis, then these tips in here would help you know I might need to go look at that manifest table and drop certain sites from my analysis and never have those rows of data appear. Or I'm now going to create a flag that's a date shift over 30 days flag. And so I can easily drop the rows of data later where there is a excessive date shift. So yeah, we're not making those decisions. I know there's a great need in the community to share the kind of best practices in terms of analytics. And we try to scope our work to really focus on this piece. It might seem overly simple, but if it does seem overly simple, then we've succeeded. Because it wasn't overly simple for many teams who began working with this data, and we do intend to continue updating it. But yeah, I think that there's the ADMS group where we have a lot of discussions about the methods and best practices there. And then of course we have also the data liaisons group where they're thinking a lot about the source data and what it really means to find, say, a drug instance in here. And these, as the bridge between the two, we sometimes have learning and tips that kind of cross into those worlds, but we're trying to avoid making those decisions because it really is going to depend on your analysis. So all we're doing is saying this is how you would create a flag for an admission. We're not telling you you might want to, just do it. You should just look at admitted patients. We're not making that judgment for you. I think that, like, how do we share those analytics?
I guess the question question is more like, provided I use the admission info that's provided by the template, do I need to then, visit with a logic liaison or somebody like that to see if that definition of an inpatient visit is appropriate, or am I sort of safe to go like, oh, this is the definition of an inpatient visit that they used and it looks okay to me, so?
Well, that's where data liaisons come in, right? So we have concept sets in here, and already pointed out the ones that were being used for admission, for example. But your logic liaison and your domain team should work with you to review every concept set, whether you're editing it through this template here, or whether you're working directly in the code. So, you know, this is, you have to make a decision as you move along about each thing here and verify, yes, these are the codes we want to use for admissions, because that applies to what we're doing. Or yes, this is what we want to use for, we want to use the cohort paper definition of whatever concept. But we know, like, it's certainly in ones we've done, like solid organ transplant, you know, there's certainly a range of what clinicians might think is appropriate for some borderline things. And so you're going to have different concept sets being used that are very valid, but there's good, reason why they're including or not including it. But we have tried to call out the places where you need to pay attention and be thinking about it. And it's either it's both in these comments here and also in the readme.
Good to know. Thank you.
But yeah, we're trying to separate the two jobs. I also think people end up not, when we're too focused on the analysis side of the questions, we forget some of these implicit decisions we're making right here when we're building logic, right? About date differences, or about what does it really mean? Are we looking at the first instance of something and why? Like for stroke, inpatient stroke, we ultimately look in our analysis at the first event of an ischemic stroke, when that first code dropped at the time of admission, because we don't want the first code, if it happened at an outpatient visit and it really represents a historic stroke, right? If someone had a stroke before. So there are things like that where we can give you little kind of tips about what we've done, but we can't make those decisions for you.
Yeah, these are all great questions. And yeah, so let me just finish up two really quick things. So we have the almost final step where we're aggregating all of the indicators that you made in the previous steps. This node will give you the demographics because it connects to the person location table. So you'll get the data partner ID, age, gender, race, ethnicity. And then we included one example of a visualization. I don't know if it worked here. Yeah, I don't know if it's running, but in the level 2 and level 3, you'll be able to see it. And that is, yeah, that's the rest of the steps in the template. Does anyone have other questions, comments, concerns? Oh, I did, I guess I did talk about it at the beginning, but this connects to the manifest table as well. So you'll be able to get information from each of the sites and then be able to choose with your team which ones to include or which ones not to include based off of their maximum shift days or other criteria that you might have.
May I ask an ultra newbie question?
Yes.
So we're trying to start a respiratory domain work group, and that some of you might be interested in. So how do we start using this template? That is just.
I think the README should walk you right through that is our hope, but we want to make it better. So if you're running into, if it's confusing, let us know, but it actually walks you through those decisions of like, how do we even have a discussion? What's our question? Who is our master group? When we're talking about these respiratory patients. Then you will have to work with a data liaison to make your concept sets for those definitions, right? When you want to go find all the appropriate codes if it doesn't already exist in the Enclave.
Yes, well, silly me, I've made a couple of concept sets using Atlas and what seemed to be reasonable. But so we'll refine them some and submit them for review. But my question is even more basic. It's not about how to use this template. It's how do you use any template? How does one?
Do you mind if I maybe take that.
Go ahead. Yes, go ahead, Saad.
So if you click on the knowledge objects again,
Yes.
I'll just show you one way. There are like a couple ways or 3 ways to do it. But if you click on the multi-node template for person level table, RT.
Yeah.
So if you see here, there's this field, which is called shared logic. And that's actually the template, meaning the code that you can import and rerun in your code workbook. So do you mind clicking on it? It will actually not show data, so it's fine. So when you click on that link, it gives you a UI with that shows you like what are the inputs of this template, what is the code, and there is a button that says use this template in my code workbook. We'll wait for it to load, but in the actions button, we're not gonna click on that because it has LDS data. But if you click on that, it prompts you to create a code workbook in your workspace, and it imports all this code and this node. So that's one way of doing it. The other way is some people prefer just copy pasting a workbook into their workbook. And so if you go back again to, or maybe RT, you wanted to show that. But the other thing you have there is the example workbooks on the right side. Those fields are actual workbooks. And so they're meant for you to like look at how it's done. And if you want, you can also just literally copy paste the nodes. The nodes are basically that square data set that has the code, and then go to your workbook and pass it, and it will pass the code in there, and you can reuse it. I don't know if that helps a little bit. I can send you some follow-up instructions if you want.
It does. Thanks, Saad.
And I can also quickly show how to import into the blank workbook. So where this is the N3C training area, and you can go into Enclave users group. We made a folder here for this template, and this is going to use Cynthia data. And if you click on a new workbook somewhere here, yep. So the README also has explains this step, but it may be helpful just to see it. So you're gonna skip this step and then click on new transform. And then here you can, if you're gonna do the regular coding, you can select one of these languages, or you can select templates. And then here you can search for any of the templates that are, is it any of the templates in the knowledge store? I'm not sure if it includes all of them.
Yeah,
just,
so any templates in the knowledge store will be there. And also templates that are not in the knowledge store, but they're within your workspace where your research project, you can also have them there.
Nice. Yeah, so here you could, I mean, the Cynthia is showing up here. So if I selected this, it might take a couple seconds, but yeah. So as I was explaining earlier, like once it does import, it's going to look different from the sample code book that I was showing earlier. I think it's just taking a few seconds.
And because it's a big template, it takes a few seconds to load the data and the code. So these like small warnings, you shouldn't worry about them. Just give it some time.
Yeah. And so some of the orientation is preserved. You'll see how the left to right is still there. So you have the input tables, and this would be the orange section, yellow, green, blue, and purple. It might just be helpful to move these down.
Right. And so for me to start working right away on my group of interest, I could substitute the stroke concept code, concept ID, for my interstitial lung disease or whatever.
Yeah, exactly. So you would replace your code set here with whichever code set you're using for respiratory conditions. And then this template will be modified. We're working in some suggestions that other logic liaisons have mentioned. So once it's modified, we might have other slots here to include even more conditions, so that if you have more than one within your master patient group definition, then you can add more than one here.
Mhm. I imagine one could kludge that by just making a logical OR between two code sub IDs.
Yeah, so
With
if
a new one.
exactly. So the other option would be if you convert to the code transform here, and then you could use the same code. So here, when I'm looking for, this is where the section where it's looking for COVID, but the section where it's looking for condition 2 here, you'd be able to replicate this and customize it to your other conditions.
Exactly. That's what you want to do more than put two together. Otherwise, you'll have a variable that represents this or that. And you probably want to keep your clinical concepts distinct from one another.
Right. Super.
We do have a number of interns this summer. Well, first, Sucheta tried using this, who is a volunteer working with us, and she used it for an equity project and was able to quickly create her fact table. And then I was just meeting this morning with our undergraduate interns who've been working in the Enclave, and they began with this and have been adding variables now around payer period and some other things that were not in here, but very fast to see these kids who've only had a couple classes ever come in here and copy and paste and move things. It's really night and day from where we started. We were working from a blank slate always takes longer. So again, thanks to everyone who's helped us get here. And I know we'll look back at this in 6 months and think it looks old fashioned, so we'll keep making it better.
Well, thank you all very much.
Yeah, thank you, Joanna and Artie. I really like the software engineering kind of flavor of this. You know, it's no easy thing to create a fairly large code base that is both navigable, both to multiple team members, but also people who are never seen it before, as well as computationally efficient and understandable. I mean, that's sort of a difficult triangle to complete. So.
Thanks. Yeah, we're going to present it to the machine learning group, and there's opportunity to maybe change their templates so that they use this as input rather than them starting from OMOP all the way through their machine learning pipeline. And we hope to work with other groups that way too. So if anyone themselves wants to contribute to our template, please let us know. You can always create your own standalone template, but if also maybe contribute a note or two here, maybe a really handy visualization to add to the end of our pipeline or something else you think would be good for the community to have. Yeah. All right.
So if anyone does have comments, you can find me on Slack. And I just remembered today that the knowledge object has a comments and Q&A section, so you can tag me in that too. Any feedback helps everyone. So thank you.
Thank you very much. We're about 10 after, so if there are no final questions, I'll say bye-bye to everybody and have a good weekend.
Thank
Have a
you.
good weekend.
Bye.